Okay, we've looked at describing graphs. How about we learn about calculating from graphs? That would be something my teacher is going to ask me to do during the test. So let's have a look and see if we can do this. So let's start off with a distance time graph. And this is slightly different to the one we had before, but that's okay. So let's see what it's going on. Again, when we do it, how about we break it into spots where motion changes. So whenever we see a different angle here, like at this point here at 5, we know that motion changes. We see motion changes again at 15, motion changes at 25, motion changes at 30, and then we finally finish at 35. Right, we're not going to do too much description of what here is. We're going to sort of look at calculations though. We're going to look at calculations, and obviously if it's a distance and time, we're going to calculate some speed. Right, so let's look at what we've seen from this. Now what I've done is I've looked at this first section, up to 5 seconds, between the starting point at 0 and up to 5 seconds. And the first thing I do is to write down what has happened, what I can see is happening. That helps to get clear in my mind what I need to do. Alright, so it started at 0, good. After 5 seconds it was 5 metres away. That's from the graph. So we're reading what's on the graph to show what's going on. So the speed during that time is distance divided by time. So it's 5 minus 0. It started off at 0. It's now got to 5. So the speed of the distance has moved that far. The time is 5 minus 0, or 5 seconds. So when I do the sums, I get an answer that the speed in that time is 1 metre per second. Not hard. Let's move to the next one. The next one where it changes. Remember I said to you we look at where the motion changes, where this angle between these two lines changes. So I've said at 5 seconds it's 5 metres away and it moved to 21. Be careful with the numbers. When I was setting up this graph it was supposed to finish at 20, but I wasn't careful enough, so it's gone to 21 at 15 seconds time. So we're reading values off the graph. So we go up the 15 seconds to the graph and we come across here to the distance and we see it's 21. So again, we put the speed in. Speed is distance divided by time. So it's 21 minus 5, right? The difference in the distance over the difference in time, which is 15 minus 5. So it's 16 on 10, or 1.6 metres per second. Again, we must tell the reader what we're talking about. So we must have the units. Hopefully this is helping. Right, let's move along to it. Changes here again. So let's move to the next section. I'm using the red boxes to go around this time. Right, so at 15 seconds, it was 21 metres away, and it stayed at that distance for until 25 seconds. Right? 15 is there, 25 is there, right? Again, distance divided by time. So 21 minus 21 is 0. So as soon as we've got a 0 in our calculation here, we know that the answer is 0. And that would correspond pretty much to, we've said it's not moving. So if something's not moving, we would think that the speed would be 0. But if you're asked to calculate, please show. Look how I'm doing this working out. Please show that. Right, another change in motion. So let's go and have a look at it. Right, at 25 seconds, it was 21 metres away. But it got closer to be 5 metres away after 30 seconds. I can read that off the graph. So at 30 seconds, I go up to the graph and across, and I see it's 5. So again, distance over time. 21 minus 5 is the distance. That's 16. And 30 minus 25, or 5 seconds. So I've got 16 divided by 5, or 3.2 metres per second. Now that'll go pretty well because that's the steepest part of the graph. So that's the highest number, and that's what we've learnt, that if the graph's really steep, then the speed's high. If the graph's not so steep, the speed will be lower. And I think we find that's true. Alright, let's do the last one. We've only got one little bit to go before it gets back. Now we see there at 30 it's at 5, and at 35 it's at 0. So distance minus time, so distance is 5 metres away at 30, 0 at 35, and we have that's the time period. So it's 5 on 5 or 1 metres per second. So that's how I'd go about breaking down my graph, answering it and calculating the speed. It's a good way of doing it, so I hope you do this too.